you. Welcome once again. I'm Mr.Benard Ochieng, teacher of chemistry. We started on large-scale manufacture of sulfuric acid contact process. The process is here. First of all, sulfur and dry air. First of all, they are taken through a furnace where they are being burnt. Sulfur is being burnt in the presence of air to form sulfur oxide. Now, this sulfur has to be dried. The dry air has to be dried. Now, from where sulfur is being converted to sulfur oxide, where there is combustion of burning of sulfur, the air must be in excess so that air and sulfur oxide should go through the system. First of all, this sulfur oxide and oxygen, before they come to what is called the converter, where sulfur 6 is being obtained, first of all, they must be dried and also purified. Remember, sulfur 4 oxide, the moment it is not dried and purified, and even oxygen, they are likely to poison the catalyst. The catalyst that is used here is vanadium 5 oxide. And generally, this sulfur 4 oxide and oxygen, the moment they are dried, the dust particles are removed by the process called electrostatic precipitation. Now, electrostatic precipitation will ensure that sulfur oxide and oxygen are dust-free. Now, the mixture of sulfur oxide and oxygen, first of all, is taken through what is called heat exchanger. The heat exchanger, its main role is to warm the mixture of sulfur and oxygen before they reach the catalytic chamber. This is just a summary. Now in here, what happens here is this sulfur oxide, the moment it reaches in this catalytic converter, sulfur oxide reacts with oxygen to form sulfur 6. The reaction is very exothermic. And indeed, a lot of heat is produced, and the amount of sulfur oxide getting inside the catalytic chamber is controlled, is regulated, so that a temperature of 450, the optimum temperature of 450 is maintained. This is what we call optimum temperature. For us to obtain sulfur 6 oxide in large scale, there are some conditions, or what we call optimum conditions, so that more sulfur 6 oxide can be obtained. Now, inside here, we have vanadium 5 oxide as a catalyst. Vanadium 5 oxide is preferred. We also have another catalyst called platinized asbestos. Platinized asbestos is not commonly used here because of two reasons. One, it is expensive. Two, it is easily poisoned by the impurities. Should dust particles get inside this particular converter, it will reduce the efficiency of the catalyst platinized asbestos. So in this chamber, vanadium 5 oxide is commonly used because, first of all, it's cheap. Two, it is not easily poisoned by the catalyst. Three, a temperature of 450. That is the optimum temperature. We know that the reaction is exothermic. Lowering the temperature will favor production of sulfur 6 oxide, but at a lower rate. And that's why a temperature of 450 is what is the compromise temperature to produce more sulfur 6 oxide. Apart from that, we also have a pressure. Remember, for sulfur 4 oxide to react with oxygen, they need to be pushed to be very close to each other so that they react on the surface of the catalyst. So in this case here, the pressure of 2 to 3 atmospheres is required so that sulfur 6 oxide can be formed. Now sulfur 6 oxide that is already formed, it is passed through this what we call absorption tower. From here, you can see sulfuric acid trickling down in form of a shower. This is concentrated sulfuric acid. This sulfur 6 oxide dissolves in concentrated sulfuric acid to form an oily-like substance called oleum, H2S2O7. Now, it is this oleum that passes through this particular tube and it is mixed with water. When it is mixed with water, it forms concentrated sulfuric acid whose density is 1.84 grams per every cubic centimeter and molarity 18.4 molar. All that I've explained is here. I've said, first of all, sulfur is roasted in oxygen and a lot of heat is produced. Platinum catalyst is also used, can be used, but it's expensive and also can be easily poisoned. And then, as I've said, low temperatures diaphragm is necessary, but the optimum temperature, a compromised temperature of 450 is necessary, and a pressure of 2 to 3 atmosphere is necessary, and those are what we refer to as the optimum conditions. As I've said, the reaction is highly isothermic, and the gas formed is taken back to the heat exchanger to heat the incoming sulfur oxide and oxygen. Remember, sulfur 6 oxide formed cannot be dissolved in water. Reason being, sulfur 6 oxide reacts exothermically, is highly exothermic. When it dissolves directly in water, the reaction is highly exothermic, and the heat that is produced is enough to boil the acid, to form boil the acid, and the acid will splash to form mist in air, and hence the acid will not be collected. And that is the reason why sulfur 6 oxide will never be dissolved in water to form sulfuric acid. Though in small quantity it will form sulfuric acid, but in large scale it may not be tenable. Now, the hot sulfur 6 oxide, as I've said, and excess air are cooled by passing them through the heat exchanger so that they can heat the incoming gases, and hence to minimize the cost of energy. And the already cooled sulfur 6 oxide, it is then connected to absorbed in the concentrated sulfuric acid in the absorption tower to form oleum, which I've said it is H2S2O7. And then finally, you obtain sulfuric acid by adding water to oleum. If you add water to oleum, you get concentrated sulfuric acid H2SO4. Generally, in this kind of industrial process, there is likelihood of some sulfur 4 oxide. Being an acidic gas, it is very possible that it can pollute the environment. Now, to ensure that it does not pollute the environment, such companies, the exhaust chimney is lined with calcium hydroxide. The essence of lining the chimney with the calcium hydroxide is to ensure that sulfur 4 oxide is not released to the atmosphere. The already lined calcium hydroxide will react with sulfur oxide, which is already formed during the process to form calcium sulfite and water. This is now harmless. This is what we call scrapping the gas, so that our air is not polluted. I've said it is called scrapping the gas. And then again, we can also the filters should be fitted with strong alkalis. Those ones can as well be used so that they remove traces of any acid and the exhaust gases. In our next lesson, we shall look at other areas, but for now, I hope you have enjoyed the contact process, and see you in our next lesson. Thank you very much. Thank you for listening. I hope you have enjoyed. Thank you.